Hello everyone, myself Gautami K from Sri Venkateshwara College of Engineering. This video is about the topic the data science process. Let's see the contents. Introduction to the data science process, problem identification, data collection and exploration, data cleaning and pre-processing, future engineering, model selection and training, exploratory data analysis, model evolution and validation, model deployment, model evolution, monitoring and maintenance, and conclusion. First, we will see introduction to the data science process. The data science is a multifaceted discipline that involves extracting insights and knowledge from complex data. The data science process outlines a structured approach to data-driven challenges from initial problem definition to final model deployment. Problem identification. The first step in the data science process is to clearly define the problem that needs to be solved. This involves understanding the business objectives, identifying the key questions that needs to be answered, and determining the appropriate data and analytical effective problem identification is critical to ensuring that the data science project stays meaningful insights that drive business value. Next, we will see data collection and exploration. First, identify data sources, understand data structure, explore and visualize, assess data quality. First, identify data sources. Determine the relevant data sources, which could include databases, web scraping, or even manual data entry. Next, understand data structure. Examine the format, schema, and characteristics of the data to understand its potential and limitations. Next, explore and visualize. Use exploratory data analysis techniques and data visualization tools to gain insights and identify patterns in the data. Assess data quality. The data for completeness, accuracy, and relevance to the problem at hand. Data cleaning and pre-processing. Data cleaning, future engineering, quality checks. Data cleaning, remove errors, inconsistency, and irrelevant data to ensure the data set is accurate and reliable for analysis. Next, future engineering, create new futures or transfer existing ones to better capture the underlying patterns in the data and improve model performance. Next, quality checks. Implement robust validation process to identify and address data quality issues, enhancing the overall reliability of the dataset. Next, future engineering. Identifying relevant futures, transforming futures, handling missing data, future selection. Identifying relevant futures, examine your dataset to determine which variables or attributes are more relevant to the problem you are trying to solve. Next, transforming futures. Create new futures by transforming or combining existing ones. These could involve scaling, normalizing variables from the raw data. Next, handling missing data. Address any missing values in your dataset through techniques like imputations or dropping rows or columns. Next, future selection. Determine the most important futures by evolving the individual and joint contributions to the model. These helps reduce dimensions and improve model generations. Next, we will see model selection and training. First, algorithm selection, hyperparameter tuning, model training. First, algorithm selection. Choose the most appropriate machine learning algorithm based on the problem, data characteristics, and outcomes. Consider factors like accuracy and computational efficiency. Next, hyperparameter tuning. Optimize the algorithm's hyperparameters to improve performance. Use techniques like grid search, random search to find the best configuration. Next, Model training. Train the selected model on the cleaned and pre-processed data. Monitor the cleaning process and make adjustments as needed to improve overfitting and underfitting. Next, exploratory data analysis. Visualize the data, understand the variable, leverage statistics. First, visualize the data. Use powerful data visualization tools to uncover patterns, trends, and insights hidden within the data. Create graphs, charts, and flows to effectively communicate findings. Next, understand the variable. Examine the dataset to understand the characteristics and relationships between variables. Identify key features, outlines, and potential data quality issues. Next, leverage statistics. Apply statistical analysis techniques to test hypotheses, measure variability, and qualify significance. Uncover meaningful insights that can inform the next steps of the data science process. Model evolution and validation, choosing metrics, cross validation, holdout testing, bias various analysis. First, choosing metrics. Identify the right performance metrics to evaluate your model, such as accuracy, precision, recall, based on the problem you are trying to solve. Next, cross validation. Use cross validation techniques like F-fold to get a robust estimate of your model's performance and avoid overfitting. Next, holdout testing. Set aside a portion of your data as a holdout test set to get an unbiased evaluation of your model's performance on new and unseen data. Next, bias variance analysis. Analyze the bias variance trade-off your model to identify opportunities for improvement through future engineering or model complexity adjustments. Model deployment, productionizing the model, and monitoring and maintenance. Once the model has been tested and validated, it's time to deploy it into a production environment. This involves integrating the model into your organization's existing systems and process. Next, monitoring and maintenance. Continuous monitoring and maintenance of the deployed model is crucial. This ensures the model performance remains high and it adapts to changes in the data or business requirements. Next, model evolution. After training a machine learning model, it's crucial to evaluate its performance. This involves assessing the model's accuracy, precision, recall, and F1 score on a head-out test dataset. Visualizations like confusion matrix and ROC curves can provide deeper insights into the model's strengths and weaknesses. Careful evaluation ensures the model is fit for its intended purpose and can generalize well to new, unseen data. This step is essential before deploying the model in a production environment to deliver real-world value to the client. Next, monitoring and maintenance. First, continuous monitoring, scheduled retraining, maintenance protocol, transparency and explainability. First, continuous monitoring. Closely monitor model performance, data quality and user feedback to proactively identify and address issues. Next, scheduled retraining. Periodically retrain and model with new data to keep it up to date and ensure it remains accurate over time. Next, maintenance protocol. Establish clear maintenance protocol to handle model updates, infrastructure changes, and data pipeline modification. Next, transparency and explainability. Maintain transparency around the model's decision-making process and ensure it remains explainable to stakeholders. Conclusion. The data science process is a powerful framework for extracting insights from data and driving impactful business decisions. As you move forward, continue to refine your approach, stay up to date with industry trends, and explore new techniques to push the boundaries of what's possible with data. Thank you for watching this video.